Class, this is a continuation of the properties of functions, the domain and range. In the last video, we looked at the idea of what are undefined points, and we also looked at two examples of the domain and range. Going over it again briefly, in this example, we looked at the domain, the x values, and we saw that there was no restrictions on the x values here because every x value is mapped onto somewhere in this function. Likewise with the range, this line can reach the highest, right? There's nothing stopping it going upwards, and there's also nothing stopping it going downwards. Okay, so in this case, the domain and range are all real x and all real y. In our second example, we saw a parabola. With the domain, there was nothing stopping it picking 3, for example. There's nothing stopping it picking positive infinity. There's nothing stopping us picking negative infinity. So our domain is all real x. And here it is in bracket notation. And we saw here that our range, right? We saw that it could move upwards, right? Whoops. You can move upwards to infinity. However, the absolute lowest point that our function can reach, the y value, is shown right here at the bottom. Okay, so because of that, our range is y is greater than or equal to 0. And here it is again in bracket notation. Let's look at two more examples of the domain and range. Here is what's known as a hyperbola. The name of this is not so important. It's more the understanding the domain and range of this. Let's take a look at x values of the domain. Are there any restrictions at all that we cannot pick? For example, I can pick 1. That will map to 1. I can pick 3. X equals 3 gets mapped onto this point, whatever it is. I can pick 8. It gets mapped on to something there. As you can see, I can pick any x value except x equals 0. Because we talked about this in the in the previous video. We saw that if I pick x equals 0, so if I do h of 0, we get 1 over 0. So that is an undefined point. We don't know what happens. So in this case, we can say that x cannot equal 0, otherwise all real x. Now, writing this in bracket notation, we can pick all negative values here. So we can pick from negative infinity, but the highest number in this interval, we have to stop at 0. So we can only get so close to 0, not including, because this is including, not including 0. Union with, well, in this case, we have positive infinity. That's the highest we can go. And once again, the lowest value we can go is very close to 0, but not including 0. So my domain here is all real x, except x cannot equal 0. Or in bracket notation, shown here. Let's take a look at the range. Just put ran. My range, let's take a look at the highest and lowest that this function can go. Let's take a look. Well, if you take a look, it's curving upwards. And if you can imagine, this is going to continue going upwards, right? And in case you're wondering, this line will never go through the y-axis. It'll get closer and closer, but never touch it. Same goes for here. it can keep going lower, but it will never touch the y-axis. Okay. But now if you take a look now at this point, the y value here, so the y value here is 1, the y value here is half, the y value here is 1/3, here it's 1/4, here is 1/5, and so on. Can you see that the y value will always be a fraction? It'll get closer and closer to 0, but it will never be equal to 0. Likewise here, this point here, y is equal to -1. At this point here, y is equal to -half. This point here, y is equal to -1/3. Y is equal to -1/4. So similarly, this function, if it continues onwards this way, it will always be a fraction. It can never, the y value will never be 0. So in this case, our range y cannot equal 0. Otherwise, all real, oops, I was about to do x, all real y. Okay, and now in bracket notation, it can go from -infinity. So here's -infinity, you can go all the way down. Okay, but then it has to stop, right? It cannot ever reach 0. So it'll go from -infinity and it'll stop at 0, not including 0. Union with, once again here, the lowest point in this portion, well, it'll, actually no, let's take a look, whoops. The highest this will go is +infinity, but then it'll have to stop really close to 0. So it'll go from 0 to +infinity. Let's now take a look here at this last example of a semicircle. So here it is drawn. I want you to think about the domain now. What are the restrictions on this domain? Or you can just look at it graphically. Where does the graph stop? Well, at x equals 1 and x equals -1. So looking at this graphically, the domain is x is less than and equal to 1, but greater than and equal to -1. Okay. Now the reason for that, let's take a look at here. Let's consider if we had square root 1 minus 1 squared. Isn't that going to be 0? Because 1, take away 1, that's 0. Square roots of 0 is 0. So that's allowed. But now let's say we take square roots of 2. Sorry. Square root of 1 minus 2 squared. Isn't that going to be 1 minus 4? Square root. And that will be square root of -3. And as I've spoken about it in the previous video, square roots cannot be negative numbers. So the largest number this can be is 1, and likewise the smallest number this can be is -1. And in bracket notation, it's -1 to +1. The range now, whoops, ran. The range of this function, what is the highest y value this can reach? As you can see here, the y value here is 1. That's the highest it can go. What is the lowest that this y value can go? Well, here this y value is 0. Well, the range then is going from 0 is less than y is less than or equal to 1. So between 0 and 1, including 1. And in bracket notation, 0 to 1. So I hope that gave you an insight into the domain and range of functions. I hope to see you in the next video. Best of luck.